All right, welcome back, everybody. Hey, sorry I'm not there with you. I just want to first off wish everybody happy Thanksgiving. I hope we all have a restful and relaxing break. I just want to go through the end of section 9.1 here. Again, today is for you to watch this video and then complete the assignment. You can turn it in by the end of the period. Again, the goal is for you to not have anything to do over the break. Again, it isn't a homework weekend, so the goal is for you to do this in class today. So as we were talking about yesterday, first things first, you should be getting two things from Mr. Mattingly. First thing is the what's that called? The regression instructions. Regression instructions, okay? That's what I showed you yesterday from Mrs. Naupolz. It kind of outlines everything that you would need to do for a linear regression. And then the second thing is this thing called Table 11. Every year I think to myself, I should really add that into the packet. But it's something that we only use one time, and it's in Chapter 9. So it kind of gets out of my memory, and then I forget about it. But you should, those two things I asked Mr. Mattingly to pass out. So make sure you do that. Also, while I'm thinking about it, for CCP students, make sure you do the survey. Okay, that is anybody who has signed up for the CCP section of this course. I just need to get you guys to do that survey. I can't be in the room that you do when you do it, so I figured might as well take time to do it now. So just make sure you do that. Mr. Mattingly has probably told you to do that, but make sure you get that done. It should be in a manila folder, and then put those sheets back in there when you're done. Okay, so we were talking about correlation coefficient, and I think we were right here. Now, this is the table 11. When I say using a table to test a population correlation coefficient, this is when I say use that table 11. I would show you as a PDF, like on the screen, but I don't have it as a document. I just scan it out of the book each year. But it's that table 11 handout. And I'm looking at it right now. You should only be looking at the right side of this table. Or I'm sorry, right side of this page. You see the table of 10 and then the table 11. I kind of scribbled out the table 10. Once you've calculated a sample correlation coefficient, you may want to determine whether there is enough evidence to decide that rho, which again is the population correlation coefficient, is significant at a given level of significance. And that should be alpha, right? And again, that's the confidence at which you can make this statement about the population correlation coefficient. So, you know what, I did another example, but why go and do another example? Let's just go back and instead of plugging everything in, let's go back to this Yellowstone example and take a look at this R value. Maybe we want to look at this R value and say, well, with that R value, and given, let's choose an alpha, let me look at the table here. Well, I guess let's take a look at the alpha 0.05 and then also the alpha 0.01. Those are the only two columns listed in your table. So let's see if this R value is statistically significant at the alpha 0.05 level and at the alpha 0.01 level. Let's see. Now, the first thing you'll notice when you're looking at your table is it's divided up by n. So I need to have n matched pairs of these things. So I think I said in our calculator here we had, I think this is n is a total of 25. There was a 25 samples, durations and times pairs. So at the alpha 0.05 level, looking at your table, look down where the n is 25 and the alpha 0.05 level, I only needed to be at 0.396. You see that? 0.396. And looking at the 25 on the right side, 0.505. So what am I saying here? I'm saying that to be statistically significant at the alpha 0.05 level and the alpha 0.01 level, my R value really only needed to be 0.396 and 0.505. What was our R value? It was 0.973. So since 0.973 is greater than 0.396 or 0.505, we can state that this R value is statistically significant, statistically significant at the alpha 0.05 and 0.01 level. Okay? So we say that it is statistically significant, right? we're going to be doing hypothesis testing here in a minute, but please understand that this is different from hypothesis testing. I am saying that is the R value statistically significant enough to make a decision about rho, right? I'm not saying what our decision was about rho, but I'm just saying, is it statistically significant? Is this R value like meaningful here? To be meaningful, it needed to be above a 3.96 for the 0.05 level and above a 0.505 at the alpha 0.01 level, which means that I am 95% sure in saying that this is statistically significant with this when it's above 0.396. I am 99% sure that this is significant when it's above 0.505. And since it was both, I mean, I guess my table's not out that far, but I bet it's like 99.9% significant as well. But again, our table doesn't do that. All right, now let's talk about hypothesis testing. Okay, so for hypothesis testing for a population correlation coefficient, we really have 3 different ways that we could put this, okay? And these are all decisions about rho. Rho could either be less than or equal to 0, rho could be I wrote it as a P, but rho could be greater than or equal to 0, rho could be equal to 0. Now, think about what this is saying. If rho is equal to 0, that means that there is no correlation, right? That is a no correlation at all, right? If rho is not equal to 0, that must mean that there is a correlation. Not necessarily saying that it's bigger or smaller than 0. I'm just saying it's not 0. I'm not saying whether it's positive or negative. I'm just saying it's not 0. Now, if rho is, looking at the second one here, if rho is greater than or equal to 0, well, then the alternative would be less than 0, right? And if rho is less than or equal to 0, rho would be greater than 0 in this location. Now, what are each of these saying? Well, this would be saying that if it's less than 0, this would be a negative correlation. If this is greater than 0, that this is a positive correlation. Notice how I am only focused on the alternative. The reason in saying that is because I want to be able to support a positive correlation or support a negative correlation. I want to prove that there is a positive or is a negative correlation, or prove that there is a correlation, right? So the only way to prove a claim, support a claim, is when I put it in the alternative hypothesis. That's why I am not really saying anything about the null. I'm saying the opposite within the null, okay? So if I want to say that there is a strong positive correlation, we want to use this. If I want to say that there's a negative correlation, I want to use this. If I want to say that there is some sort of correlation, not stating positive or negative, I want to use this. Now, I think I highlighted it yesterday, but here is my t-score that I am going to use. Okay, here is the t-score that I'm going to use. Now, a t-test can be used to test whether the correlation between two variables is significant, whether significant positive, significant negative, or just significant overall. This R value comes from your calculator, basically. Okay, so I think I want to do. You know what? Let's revert this back to. Our original problem here for Yellowstone. Yeah, let's do a test over. Let's do this alpha 0.05 and say claim of a positive linear relationship, which we had said, right? A positive linear relationship based on this data. Let me jump all the way back to here. Okay, let me get all this junk out of here. I need this R value still. And let's say that there is a positive linear relationship. Okay. A positive linear relationship. Okay. And that's our claim. Right? So what does that mean? Is that means that rho is greater than 0. Right? That rho is greater than 0. Now, if that's my claim, that means my null is rho is less than or equal to 0. So my alternative, which can be proven here, is greater than 0. Okay, so let's run our hypothesis test. Let's figure that out. I think we said at the alpha 0.05 level. Let me just run back and check that real quick. Yep, the alpha 0.05 level. Okay, we're checking it at the alpha 0.05 level, and we had seen that the R value was 0.973. Let's just round it to right there. Okay, so let's figure out our rejection region. Yeah, rejection. Still cannot spell rejection region here. And again, if this is a positive, look here, right-tailed test greater than 0, right? It's going to end up right there. Let's find out our critical value, our TC. Now, we remember our n minus 2 degrees of freedom. I talked about that yesterday. I'm going to go back to my t-table. I've got a blue sheet right here in front of me. I'm going to go back to my t-table. And I see I had an n equals 25. So my degrees of freedom is 23, n minus 2. So I'm looking at my 23 row, and I see one tail alpha 0.05 to be 1.714. 1.714. So that means my rejection region is that if t comes out to be, because this is a right tail, greater than 1.714, then I can reject my null, therefore accepting my alternative. Right? Okay, so let's see what our t-score actually comes out to be. Again, our t-score, I'm just going to look at my blue sheet here in chapter 9. You can hear me flipping my pages. Okay, we've got, where is that? R over square root of 1 minus r squared over n minus 2. Okay. So let's run that value. Okay, let's run that value. We have R 0.973 divided by, okay, inside we've got a radical, and I've got 1 minus 0.973 squared. Oh, there's a decimal. I lost my minus. Hold on. Insert a minus. 1 minus 0.973 squared, good, there we go, divided by n minus 2, my degrees of freedom. Just double checking that, perfect. Whoa! Did I do that right? Hold on a sec. 1 minus 0.973, is that 1 minus r squared? 0.973 squared divided by 23, and then r 0.973 divided by that. Why did I get two very different answers? Okay, I'm going to run that one. Oh, I forgot to square root it, you turd. Oops, I forgot to square root that. Okay, I got to go back to that. 1 minus 0.973 squared divided by 23. I forgot to square root it at this point. Square root, my answer. Okay, now I'm going to take that. I'm going to take 0.973 and divide it by that. Yeah. Well, okay. I do get 20.22. 20.22. So because 20.22 comes out greater than 1.714, we can say that we can reject. And reject my null, not reject my claim. So we can reject the null. Actually, I should really put this in terms of the claim. We can support the claim, reject the null, therefore supporting the claim that there is a positive correlation at the alpha 0.05 level. Yeah. And that is making the statement about rho. We used R to make that statement about rho. Okay. So your homework for the rest of the time in class, we got these 5 problems, 9, 21, 25, 27, and 33. All right, I hope we have a great break. I'm so sorry I can't see you off there tomorrow or today for you, but I hope we have a great break. And yeah, so long.